So when we're trying to make our LLMs better, what do we usually think of, right? Bigger models, smarter prompts. But what if there was this kind of hidden optimization that could just slash your costs and your latency? We're talking up to 90%. Yeah, you heard that right. Today we're going to dive deep into the super powerful world of prompt caching. All right, here's the plan. We're going to start with a problem every single developer knows all too well. Then we'll peek under the hood of an LLM to see what's actually going on. After that, we'll see how caching is the answer and the huge benefits it brings. And stick around, because we're going to cover the one single rule you absolutely have to follow to make any of this work. All right, first up, the high cost of context. And this is a pain point that pretty much anyone building with AI feels deep in their soul. It's that constant struggle of using these big, rich contexts without, completely draining your budget or making your users wait forever.
So is your AI application just too slow? You know the feeling, right? You build this amazing, sophisticated agent, you feed it all of this great information, and then you just wait and wait. That delay, it's an absolute killer for the user experience.
And is it also way too expensive? Because that's the other side of the coin, isn't it? Every single one of those slow requests with that huge chunk of context, you're paying for it. And those API calls pile up so fast, your cool prototype suddenly looks like a money pit.
And look, we're not talking about a small issue here. Check this out, 53,050 tokens. That's how much a typical RAG system might have to process for just one user question. Now just imagine doing that over and over and over for every single turn in a conversation. It's just not sustainable. Okay, before we get any deeper, we have to make a really important distinction here. We are not talking about simple output caching. That's just, saving the final answer. If someone asks the exact same question, you spit out the same answer. No, what we're talking about is prompt caching. This is totally different. It's about storing the internal work, the heavy lifting, so you can optimize the new calls you actually have to make. So to really get why this is such a game changer, we have to go inside the LLM's engine. Yeah, we're going to crack open that black box and see what's actually happening under the hood that makes all of this possible. Okay, this is it. This is the absolute key to everything. Before a large language model writes even a single word, it first has to read the entire prompt you gave it. This first step, which is super computationally expensive, is called the prefill phase.
So during that prefill phase, the model is doing some serious number crunching. It's creating something called key-value pairs, or KV pairs. The best way to think about this is it's the model's internal cheat sheet for your prompt. It's this complex map of how every single token relates to every other token. And yeah, building that map, that's the really, really hard work.
And that brings us right to the prompt caching solution. It's such an elegant idea, really. It leverages this internal process by basically saying, hey, why do all that hard work again? Prompt caching just saves that cheat sheet, those pre-computed KV pairs, so the model doesn't have to rebuild it from scratch every single time.
And this visual, wow, it just shows the difference so perfectly. Look at the without caching side. Every single request is this huge heavy lift. It's a ton of redundant work. But then you look at the with caching side, and it's just this quick, instant load of the work you've already done. That's what slashes the latency and the cost.
So let's break down how this works. It's actually really straightforward. First, the system looks at your prompt and finds the part that's always the same, the static beginning. Then, instead of recalculating it, it just grabs the pre-computed KV pairs for that part right out of the cache. Instantly. That means the model only has to worry about the new part, like the actual user's question, and boom, it can start generating the answer almost immediately. All right, now for the really fun part, the 90% cost reduction. Let's talk about the real-world impact this has on your speed and, maybe more importantly, your budget. Because we're not talking about some small incremental improvement here. This is a total game changer. I mean, the cost savings are just staggering. Take a look at this. Major providers are charging up to 90% less for these cache tokens. The price plummets from $3 per million tokens all the way down to 30 cents. Think about that. At scale, that is an absolutely massive amount of money you're saving.
And the speed? The impact is just as insane. Without caching, if you've got a large context, you could be waiting more than 10 seconds just for the first word of the response to show up. In a chat app, that's an eternity. The user's already gone.
But turn on prompt caching, that time to first token drops to less than half a second. Less than 500 milliseconds.
The entire feel of your application transforms from sluggish and painful to snappy, responsive, and truly conversational.
And look, this isn't just some theory on a slide. Let's look at a real-world example, Klarna's AI agent. They handled 2.3 million conversations. They kept the resolution time under 2 minutes. They did the work of what would have been 700 full-time agents. And the result? An estimated $40 million boost to their annual profit. That, right there, is the power of designing your system efficiently.
Okay, so this all sounds amazing, right? But you can't just flip a switch and have it work automatically. To get all these incredible benefits, there's one really simple but absolutely critical rule you have to follow when you build your prompts.
And here it is. It's this simple. Your static content must come first. All the stuff that doesn't change has to be at the very beginning of the prompt. Why? Because most caching systems use what's called prefix matching. It's a fancy way of saying the cache only works if it sees the exact same start to a prompt it's seen before.
So here's what a good cache-friendly prompt looks like. See? You put your system instructions first, that's static. Then you add your document context, also static. And only at the very end do you put the one thing that changes, the user's question. Perfect.
Now this is a bad prompt. This will break your cache. If you start with the user's question, which is different every time, then the prefix, the beginning of the prompt, is always new. The cache will never, ever find a match. You'll get zero benefit and force the model to do all that heavy lifting again and again.
And all of this brings us to the most important point. We need to understand why caching is so critical. This isn't just some neat little trick anymore. It's moved way beyond that. For any serious AI application you're building today, this is an architectural necessity.
So who really needs to be doing this? Well, if you're building an AI copilot that needs to know about an entire codebase, you do. If you're building a chat with your data RAG app and you want it to be, 10 times faster and cheaper, you definitely do. Building agentic workflows that run in loops, you'll save a fortune. The bottom line is, if you're building any kind of serious AI app, this needs to be on your radar.
So let's wrap this up with a final thought. We're all obsessed with bigger, more powerful models, but the future of AI is just as much about smarter, more efficient system design. I love this quote. Latency is the new downtime, and cost is the new technical debt. Think about that. Mastering something like prompt caching, it isn't just a nice-to-have optimization. It's a core skill you need to build the next generation of AI.